All right, welcome back, guys and gals. We're still dealing with functions, but today we're going to kind of take a turn. We've already dealt with things like slope, rate of change, or y-intercepts, initial values. Today we're going to put all of it together, and what we're going to work on is called graphing linear functions. So we're actually going to take things like word problems and equations and actually create the graphs ourselves. So instead of me providing you the graph, you're going to give me the graph, right? And we're going to do it a couple ways. Obviously, here I'm going to show you how to do it paper, pencil, and then in class today, I'll show you how we could do it, say, on a Google document or a Google form. That way, you can submit your work digitally instead of having to draw everything out. But again, I would strongly encourage that you either print out the notes or print out some graph paper. I'll leave some graph paper out at the school so that way you can draw your X and Y axis and practice doing this, because again, you'll need to know how to do it both ways. So before we get started, let's review real quick a couple issues dealing with slope and y-intercepts. So let's start with slope. I'm going to write it up here just because I'm out of space. Remember, all slopes are rise over run when we write them as a fraction. So the top number tells me how far up or down, all right? And then the bottom number is always going to tell me the direction to the right. So keep that in mind. Rise is always up or down, and then run, that bottom number, is always to the right. Keep that in mind. The second issue is with y-intercepts. All right, just a quick review here. Remember, all y-intercepts follow the format 0, comma, a number. All right, whatever that number happens to be. And that number is where our line will cross the y-axis. So we've got to keep these ideas in mind as we graph. So the first thing let's do, let's look at equations and how we can take those equations and represent them as a line on the page. So let's start with this one here. We'll kind of work our way around. But here's what we're going to need to know. If we're going to graph lines, or linear functions rather, with these equations, a couple things. First, we're going to use the y-intercept to plot our starting point. And again, I use that term kind of loosely. So for example, in this case, I've got y equals 2x plus 1. And remember, our format is y equals mx plus b, where b is the y-intercept. So in this case, my y-intercept is at 0, 1. Remember, all y-intercepts look like 0, comma, a number. And in this case, my number is 1. That b that we're either adding or subtracting, as the case could be, is our y-intercept. So in this case, I'm going to plot my first point at 0, 1, right there. All right. Next thing I'm going to look for is we'll use the slope to count from there. All right. So notice our slope in this case, our m, in this case, is a 2. Well, notice it's not written as a fraction. Remember, we said all slopes are rise over run. So if I've got a whole number of 2, I could rewrite that as 2 over 1. Since the 2 is positive, that's telling me I'm going to go up. And since we have a 1 here, remember 2 over 1 is just another way of saying 2, this number always tells me how far to the right. So here's what I'm going to do. From this starting point, I'm going to use my slope to count up 2 boxes and then right 1. So here we go, up 2 boxes. So 1, 2, and then right 1, make a point. Up 2, 1, 2, and then to the right, make a point. All right. And once I get enough of these, I can then draw my line in. Now, obviously, we could go in the reverse, right? Going up and then right. Well, notice that only gives me half the line, right? Our line actually runs through the entire grid. So to go the other direction, so let me change color here. To go the other direction, so to the left of this point, I'm going to do the opposite. So in this time, 2 over 1, I'm going to go down 2 and left 1. So that way I can get the other side. So down 2, left 1. Notice these are all falling in line. Down 2 and then left 1, down 2, left 1. And notice these all fall in line. If I tried to go up and left, well, notice that would give me some sort of V pattern here. I want them all in line. So once you get enough points that you feel comfortable, do not eyeball it. Grab a straight edge. So I'm going to use a piece of paper. If you want to use a ruler or protractor or something, that's fine. And we're going to connect the dots, and we want to fill up the page as much as we can. Just like my old art teacher in school used to tell me, fill the page. Right? And there we are. So there's our graph. Now let's double check it just to make certain that we've done it correctly. So our y-intercept should be at 1. Sure enough, we've crossed at 1. Our slope is positive, so this line should go up. And since it's a slope of 2, between every point that I've marked, I should be able to go up 2 and right 1 and get to the next point. So for example, down here, up 2, right 1, up 2, right 1. And it seems to be working. So that looks like a good graph of this line. All right, let's try another one. let's try this one, for example. So let's look. We've got a subtract 4. So remember, we said y equals mx added to b. So we really want that to be addition. So let's just rewrite this. So we'll write add a line, change the sign. So it's at -4. So our y-intercept is at 0, -4. So I'm going to come down to -4 and make my mark here. Cool. Now let's look at our slope. Remember, slope we said is rise over run. So let's look at it. It's a +3 over 4. So since it's positive, I'm going to go up and then to the right. So from here, I'm going to count up 3. So 1, 2, 3, and then to the right 4. 1, 2, 3, 4. So up 3, 1, 2, 3, and then right 4, 1, 2. Well, it looks like I've run out of space. So that next point would be somewhere in here, but it's off grid. So I'm not going to graph it. All right, let's try the other direction. Remember, we said to graph the other direction, we just reverse everything. So if I want to graph to the left here, instead of going up and to the right, I'm going to go down 3 and then 4 to the left. All right, so that way I can graph the other side. Well, in this case, I can't even go down the 1, 2, 3. So that point, again, would be somewhere over here off grid. Okay, fine, whatever. We won't be able to draw it. So in this case, we're going to have to draw our line with just 2 points. And as it so happens, we only need 2 points to graph a line. We try to get as many as we can, so that way we know we've got it nice and straight. But technically, you only have to have 2. So jot that down somewhere. You just need 2 points to graph. But again, I would get as many as you can. It just makes it easier to line things up. So let's grab our straight edge. We'll line up these 2 points. Draw our line. Again, try to fill up that grid as much as you can. So I've gone from one side to the other here. That looks good. Let's double check it. We've got a -4, so crosses at -4. And then to go from point to point, we should be able to go up 3 and right 4. So up 1, 2, 3, right 1, 2, 3, 4. Positive slope. It's trending upward. Looks like we've done it right. All right, let's try another one. All right, this one looks a little bit different. We've got y equals -1/2 x, and then that's it. Oh boy, so where to start? So remember, if we're not adding or subtracting anything, we can say +0 and not have changed anything, right? Adding 0 doesn't affect the function. So that would be our y-intercept. So in this case, we're going to cross the y-axis at 0, 0. So let's plot that point. It's right here. So if you're not adding or subtracting anything, we start at the origin. All right, let's look at our slope. Now notice it's negative. We're always going to put negatives with the top number. So in this case, -1/2. All right, whenever you have a negative like that with your fraction, always put it up top. It just makes life easier. Since it's negative, we're going to go down this time. So we're going to go down 1 and right 2. So let's start from here. We're going to go down 1, right 2, down 1, right 2, and so on. So down 1 box, and then right 2 boxes, make a point. All right, down 1, right 2. All right, down 1, right 2, and it looks like we've run out of space. All right, so that gets that half of the graph. But notice there's still the rest of it we could do. So to get that other side, we simply reverse everything. So instead of going down 1, we're going to go 1 up, and we're going to go 2 to the left. All right, so that'll get us the other way. So starting from the origin, we're going to go up 1 and then left 2. Up 1, left 2. Up 1, left 2. And then that lets us finish out the line so we can fill up the page. Looks good. All right, let's graph it in, and then we'll double check ourselves just to make certain that we've got it right. My sticky note's almost too short. There we go, right like that. Cool. And we always put arrows on the ends of our lines to represent that they go in both directions infinitely. So let's take a look. Starting at the origin, it looks like it. Our slope we said was down 1 and then right 2. So notice down 1, right 2, down 1, right 2, down 1, right 2. It works all the way through. Looks like we've done it right. Negative slope, so line trends down. Yep, everything's matching up perfectly. Looks good. Let's try one more. All right, well, this one's kind of different too. Notice this is y equals a number. And we said if that happens, if there is no x, that we could rewrite that function as y equals 0 times x, and in this case, +3. So let's start with our y-intercept. In this case, we're adding 3, so the y-intercept is at 0, 3. So let's go up. So left or right, we won't go left or right, but we're going to go up 1, 2, 3. So there's our y-intercept. And let's talk about slope. Well, notice we said slope in this case is 0, because 0 times x is just 0. 0 plus 3 is 3. That's why we just have y equals 3. Well, with the zero slope, remember we said if we were to graph that line, so there's a quick XY axis, we said that the line would simply be flat, right? Straight across. That's what a zero slope looks like. So in this case, I'm not going to have to plot any more points. I'm just going to take my straight edge. And since it's a zero slope, I'm going to graph simply straight across, assuming I can hold that piece of paper still. There we go. So we just go straight across, and there it is. So y equals 3 is this horizontal line right through there. Obviously, we pass the vertical line test its function. And there we are. So zero slope, right? Doesn't go up or down. That looks good. Crossed at 0, 3. Yep, sure enough, it looks good. So again, that's how we graph with equations. Let's talk about with word problems, right? How do we make that happen if we're given, say, a word problem and not the actual equation or the function rules it's sometimes called? Let's take a look. Here's how we do it. If we're graphing linear functions with word problems, all right, first thing you want to do, see if you can construct an equation. And remember, in order to do that, you're going to need to find the slope and the y-intercept. So for example, if I knew my slope was, say, 3, and my y-intercept was -2, well, then I could use those numbers. Oops, if I can get my camera to refocus. Cool. So if my slope was 3 and my y-intercept was -2, I could write that equation as y equals 3x added to -2, right? And there it is. And we could graph that because we've already learned how to do that. If for some reason that doesn't work, all right, maybe they don't give you the slope or they don't give you the y-intercept, all right? Well, in cases like that, see if you can find 2 points and graph those. Because remember, we said so long as you have 2 points, you can graph a line. Again, we'd prefer more points, but if we don't have those, it's okay. We'll go from there. So let's try some examples. First one here, it says, Mr. Lamar is mowing grass this summer to earn extra money. For every yard that he mows, he gets paid $20. All right. He has $40 saved from last year. Graph our situation. All right. Well, let's start off. Do we have a rate of change? Kind of looks like we do. It says every yard, right, gets you $20. So in other words, $20 for every 1 yard mowed. So that looks like a slope. So let's hold on to that. So that's M. Okay. Let's see if we have an initial value, a starting point. Well, it says that we have $40 that was saved from last year. So it looks like that 40 is going to be B in our equation. So remember, our linear functions look like this, y equals mx plus b. In this particular case, we know the slope is $20 a yard. So let's rewrite it. So y equals 20x. And then we've already got $40 saved up from last year. So plus 40. And there's our function. We know how to graph this. We just did it over here. So let's start at 40. That's our y-intercept. So we'll start at 0, 40. So let's see if we can find that. So notice this is counting differently, right? Our scale on our axis is different. It's not just 1, 2, 3 anymore. It's 20, 40, 60. So be careful as we're counting, right? We can't just count 1, 2, 3 anymore. We've got to be careful if it's changed. So in this case, we'll start at 40. So right here, let's look for our slope. All right, we said our slope was 20, so that's rise over run. So 20 up and then 1 to the right. Well, notice each of these boxes going up and down counts for 20. So I'm not going to count 20 individual boxes. I'm going to count what it's worth. So from here to here is 20, from 40 to 60. So up 20. And then notice on the x-axis, they are still counting in ones. 1 yard, 2 yards, 3 yards, and so on. So up 20, right 1. Up 20, right 1, up 20, right 1. And you're getting the image there. So up 20, right 1, up 20, right 1, so on and so forth. Now we'll take our straight edge. We'll graph it. And let's see if we can hold that still. There we go. Now, in this case, I'm only going to draw my arrow in one direction, simply because it doesn't make sense to draw it the other way. I can't do a -1 yard. That doesn't make sense. So let's double check. Did we start at 40? Yes, we did. We're up 20, right 1, up 20, right 1. So for example, if we were 6 yards into mowing, looks like we would have $160 in the bank. All right, and that makes sense. Looks good, positive slope. Looks like we've graphed it correctly. All right, let's try another one. With this one, Mr. Moss had 20 pounds of cat food at the start of the month. Cool. It says his cats ate half a pound each day. Graph our situation. Well, the numbers are a little small here, but notice for the number of days here at the bottom, they're counting by twos, so 2, 4, 6, 8, and so on. Notice also for the pounds of cat food, it's also counting by twos, so 2, 4, 6, and so on. So remember, when we're counting, we can't count 1, 2, 3, 4. We're counting 2, 4, 6, 8, and so on. So let's get our equation out. So remember, y equals mx added to b. Let's see if we can find ourselves a rate of change. Well, I found one pretty quick. It says half a pound each day. So let's write that out. So 1 half. Now, why did I do that? Why did I write 0.5, or rather a 0.5 as 1 half? Let me tell you. When we're graphing, fractions are easier. All right, trust me on this. It'll make sense in just a moment. So this is our slope. Decimals are a pain. Let's see if we find a y-intercept. So where does this start? Well, it looks like at the beginning of the month, it even has the word start in it. It says he starts the month with 20 pounds of cat food. So that must be our y-intercept. So let's write the equation. So y equals our slope. We said we don't want to write it as a decimal. We're going to want to write it as a fraction. So 1 half x plus 20 pounds of food to start. Cool. There it is. So let's start with the y-intercept. We're going to graph it 0, 20. And in this case, that's all the way up here. So I'll make my mark right there at the 20. Looks good. Now, here's why I had you do the not the y-intercept, but the slope as a fraction, not a decimal. Notice we want our fractions here, our slopes, to be rise over run. You really can't do that with a decimal. So we're going to go up, since it's positive, we're going to go up 1 and right 2, right? Doesn't that make sense? Well, let's think about that. Are the cats giving Mr. Moss food? Think about that a minute. It doesn't read his cats gave him a half a pound. How does it read? It says his cats ate. Oh. If they are eating the food that he's providing, well, that means we're losing pounds of food, not gaining. So be aware of that. Sometimes in these word problems, they're not going to come right out and say, well, this needs to be a negative 1 half. There's going to be clues in the problem. So in this case, by eating 0.5, it's a negative 1 half. So let's rewrite this. We're not going to go up 1. Instead, since it's negative 1 over 2, we need to go down. So down 1 and then right 2. All right, so let's do that. Now, notice, we really can't count 1, 2, 3, 4, right? We can't do that here. So counting down 1 and then right 2 is going to be sort of difficult. We'll end up in partway places. So listen carefully. If, and this is a big if the numbers that you count by on the x are the same as the numbers you count by in the y, then you may count 1 box and 2 boxes. I'll say that again. Notice how our x counts by 2, 4, 6, 8, and so on. Notice how our y counts by 2, 4, 6, 8, and so on. If they count by the same scale, the same amount, then we can treat the boxes as 1, 2, 3, and so on. Take a look. If I go down 1, right 2, 1, 2, down 1, right 1, 2, let's see if those points are actually in the right spot. So for example, if we're at day 8, it says we should only have 16 pounds of food. So let's double check that. So let's take half of 8. All right, well, that's 4. Notice it needs to be a negative 4. Negative 4 plus 20, sure enough, is negative 16, or excuse me, positive 16. We've done that correctly. So again, if this scale and this scale are the same, so 2, 4, 6, 8, again, 2, 4, 6, 8, then you may count the slope as just 1 box each. So in this case, down 1 and right 2. So down 1, right 2, down 1, right 2, down 1, right 2. You get the idea. And we'll try to get, yep, that looks about as far as we can go. Well, let me grab my straight edge. We will try to graph this in. Looks like we'll have to move it because our straight edge isn't quite long enough. There we go. And again, we want to be as accurate as possible, so use a straight edge. So let's check it. Did we start at 20? Yes, we did. We said our slope is negative because the cats are consuming the food. They're not providing it, they're consuming it. So it's trending down. And we said 1 over 2. So down 1, right 2, down 1, right 2. And that seems to be working out just fine. All right. Well, let's talk about word problems where things maybe aren't as obvious. All right. So take a look. Miss Davis wants to rent a tent for the 8th grade to use for the end of year activity. So maybe for a promotion ceremony, that kind of thing. Who knows? It says if she rents the tent for 2 days, the cost will be $250. If she rents the tent for 4 days, the cost will be $400. And we're asked to graph the situation. Well, notice I don't have a slope or a y-intercept very obvious in this problem. So let's look at our second option. All right, it says if you can find 2 points, okay, we can use those to make the line. Because remember, you only need 2. Well, as it turns out, this problem does give us 2 different coordinates that we could graph. Notice days is input, the cost is output, so x and y. So days is the x. So notice for 2 days, let's write our coordinate. The x coordinate would have to be 2. Our y coordinate is 250. All right, well, let's graph that point. So we'll go over 2 and then up to 250. So it looks like about here. Excellent. Let's graph the next one. It says if she rents it for 4 days. All right, so who knows? Maybe we've got multiple activities we're doing, so we'll need it multiple days. So for 4 days, and it says the cost of this go around is $400. So there's our second point. So let's graph that. So here's day 4. We're going to come all the way up here to the 400 mark. Goodness gracious, that's right at the very top of our graph. All right, well, let's play connect the dots. And again, we want to draw the line as long as possible. So we want to try and fill up that grid as best we can. There we go. Excellent. Now notice what we've done. By graphing the line, we've found a couple of things. First, we found the y-intercept. It looks like the initial cost for the tent is $100 up front. So let's write out the equation just for practice. So y equals, we know at the end we're going to add 100 on. All right. Let's see if we can find the slope. It looks like in this case we're going to go up 50, another 50, so that's 100, another 50, so that's 150 for 2 days. Let me write that out. 150 for every 2 days. Let's try that. So up another 50, 100, 150, and then over 1, 2. So that slope seems to work. But I don't know about you, 150 over 2 sounds sort of cumbersome. Let's divide that out. So if I took 150 and divided by 2, that's $75 for every 1 day. So we can write that in as our rate of change. We could write it in as just simply 75. So it looks like $100 up front and then $75 a day thereafter for us to rent the tent in this particular situation. Right? But there's our line. Notice it goes up because it's positive. We're having to pay more money each go. And of course, we're starting at 100 before we even use the tent. We're going to have to pay $100 up front. Maybe that's a setup fee or something. So there we go. Let's try another one. Mr. Morris looks like he's going to get into things. So Mr. Morris has found a different company to rent the tent from for the 8th grade. All right, let's see what he found. It says the cost is $50 per day. I don't know about you, but I'm going to go ahead and mark that with an M. That kind of looks like a slope to me, $50 per day. So let's hold on to that. And then it says if Mr. Morris rents the tent for 2 days, the cost is $300. And it asks for us to graph the situation. Well, notice we found a slope, cool, but we don't have a y-intercept. All right. Our other option we said is to find 2 points and use that to make the line. We're kind of at a weird spot. So here's what we can do. There's a couple of options. One option is to take the information we know and try to find the y-intercept. For example, remember we said y equals mx plus b. All right. Where m is the slope, so let's write that down. So 50. We said we need an x and a y. Well, sure enough, we've got an ordered pair right here. 2, 300, where 2 is the number of days. Let's write that in. And y is the cost, so 300. We can solve this equation real quick and figure out b. 2 times 50 is 100. If I subtract 100 on both sides, we would get 200 equals b. So this is one option for us. Now that we know where we start, our intercept is at 0, 200. I can plot that point right here. We know the slope, right? The slope we said was $50 a day. So I can go up 50. And notice we're counting 1, 2, 3, 4. So up $50 for every 1 day. Up $50 for every 1 day. Up $50 every 1 day, and so on. So there we go. And let's graph it. So this is one way we could have graphed this line. Let me show you a separate way. Oh, there we go. All right, take a look. Another way to do it is to go ahead and plot a point at 2, 300. So let me do that. 2, 300. And sure enough, there's that point. And then we could have used the slope and just simply counted from here. So up 50, right 1. Up 50, right 1. Or we could reverse it, down 50, left 1. Down 50, left 1. And that still would have gotten us onto the exact same line, the exact same way. One of these options allows us to find the y-intercept algebraically. The other one would allow us to count it out and still find that that y-intercept is at 200. So this is what we're going to be doing today. You'll be given word problems that you'll need to graph out. Again, I would recommend that you try it by hand and then try your hand, no pun intended, at doing it online. The other option we'll be looking at is taking our equations. So for example, y equals 2x plus 1 and graphing that. And again, make sure you're practicing by hand as well as on the computer so that you'll be good to go. If you have any questions or concerns, again, bring them with you to class and we'll talk about it. Have a good day, folks.